So for this part of Redox, I'm looking at the bottom of page 202 in the notes and the top of page 203. This is the part in Redox where the vocabulary can get a little bit tricky, because we have our actions of being oxidized, being reduced, and now all of a sudden we start seeing these terms with the word agent in them. So an agent is a job versus an action, what it does on its job. So the reducing agent, I sometimes like to think about as being a stressed out mom. So this is a stressed mom. Okay? Stressed mom has had a very long week with the children, and stressed out mom really wants to have a day at the spa or go on some sort of hike, have some mom time. But stressed out mom knows that she just can't walk out of her house and leave those crazy electrons unattended. So for stressed out mom, in order to have her day out, her day of relaxation, she needs to find a safe home, so I'm going to put that in quotes, for its unwanted electrons. And when stressed out mom, the reducing agent, finds a safe home for the electrons, it now can go through Leo. It can now give those electrons away and not have to worry about them. Once when the stressed out mom, the reducing agent, loses or gives away the unwanted electrons, it's able to have a configuration like a group 18 element. Now the oxidizing agent, I like to think about as like a creepy guy in a van. So creepy guy in the van, and the creepy guy in the van is driving around and is trying to find electrons to kidnap. So he's a really bad guy. And when the oxidizing agent has found electrons to kidnap, it is now able to go through the GUR process and gain those electrons and have a configuration like a group 18 element. So the reducing agent's job is to find a home for unwanted electrons, and therefore it loses electrons, and the action is oxidation. Versus the oxidizing agent, it wants to gain those electrons, and once when it gains them, it becomes reduced. So let's look at one example. So at the top of page 203, we have this reaction, and you should be able to assign oxidation numbers pretty quickly. So Zn, representing an element, 0. HBr is a compound, so we need to assign oxidation numbers that sum to 0. Hydrogen's present, bonded to a nonmetal, +1. The other guy must be using -1. On the other side, H2 represents an element, so we quickly assign it an oxidation state of 0, and then we have our compound. Now, Br is in group 17, so it's a group 17. It's functioning as a halide, so it's using a -1. There are 2 of those Brs in the formula, 1 Zn cation, so it must be using a +2. Second step, cross off any spectators, structures that maintain the same oxidation state on both sides. So now I see Br is a spectator, everything else shows a change in oxidation numbers. Okay, so I always like to have that little chart on the side so that it helps me track what is going on with oxidation numbers. So if I'm going up the ladder, it's a Leo process, and if I'm going down the ladder, it's a GUR process. So take a look. Zn, it starts off as 0 and becomes +2. So 0 to +2 is going up the ladder. So the Zn is our oxidation, so Zn0. It wants to form Zn with a +2 charge, and now I need to balance the charges by putting electrons in there. So by placing 2 electrons on the product side, the total charge on the right, +2 plus -2 is 0, and that's my total charge on the left. if I take a look at the H's, it starts off with a +1 to a 0. So if I look at my ladder, +1 to a 0 means I'm going down the ladder, so that's a GER process. So my H plus wants to form H0. It's one move between H plus and 0, so one electron. And so I place that one electron on the reactant side. So now -1 plus +1 gives me a total charge of 0. And now I have also a 0 charge on the product side. Now I look in my oxidation, 2 electrons lost, only 1 electron gained. So that means I need to balance my charge between the two half reactions. The one with the lesser number of electrons, I will multiply through by a 2. So now you're looking at this reaction, and on a test you could be given this one reaction and asked any 4 of these questions. What is oxidized? What is reduced? What functions as an oxidizing agent, or what functions as the reducing agent? Now, the thing is that this answer needs to come from the reactant side of the reaction. And if you notice, what's left in our reactant side? Zn0 and H plus, because Br is a spectator. So I'm going to box these guys in. These must be our answers for those questions. So now, the species oxidized. So oxidized, that's Leo, right? So when I take a look, and I look at my oxidation reaction, Zn0 went through oxidation. The species reduced, that is GER, and I take a look at my reduction, the H plus gains the electrons. Now we get to those agents, and this is where the vocab can get tricky. So reducing agent, this is stressed mom. So this is my stressed out mom. Mom wants to be able to get rid of electrons. So that's a Leo idea. Oxidizing agent, that's the creepy guy in the van, wants to kidnap electrons. So that's the idea of GER. So here we go. So which of these two structures, when you look at their half reactions, shows a gaining of electrons, aka kidnapping the electrons? That would be the H plus. Which one of these two is the stressed out mom? Needs a day off, needs to send the electrons away. So if we take a look, Zn ends up losing 2 electrons, so the Zn0 is our reducing agent. Now, as you know, we have that silly saying, Leo the lion says GER, right? And because the vocab gets a little bit tricky here, a few years ago some of my students said that they were renaming the lion, Leo, to his girlfriend's name, and so they started saying it as Leorora the lion says GER. And so the girlfriend's name, lose electrons, oxidation, function as the reducing agent.